All right, welcome. Today, we're going to take a whirlwind tour through, about 13.8 billion years of cosmic history. We're going to explore everything from our own planetary backyard to some of the most bizarre worlds and mind-bending physics that run the entire universe. So let's dive in.
And trust me, this isn't just any journey. We're talking about a trip that spans billions of years and distances that are, well, pretty much impossible to imagine. We're exploring the very fabric of space and time itself.
You know, that's really the magic of astronomy, isn't it? It takes the biggest story you can possibly think of, literally the story of everything, and brings it right here, to us. So what exactly is this field that can tackle such a monumental task?
Okay, let's start with the basics. Before we can really appreciate all the amazing stuff out there, we kind of need to know what it is we're looking at.
So at its core, astronomy is just a big subject. I mean, it deals with scales that are so hard to wrap your head around. Unbelievable distances, gigantic sizes, and truly, truly deep time. It is, quite literally, the study of everything.
And what's so cool about this is that the universe isn't some static, unchanging painting hanging on a wall. Nope. It's a dynamic, evolving place. It's got a history, a whole story of creation and change that has produced the most incredible sights you can possibly imagine.
And this timeline, wow, it just illustrates that story perfectly. Our entire cosmic history, all the way from that first spark of the Big Bang 13.8 billion years ago, through the birth of the very first stars, the formation of galaxies, and then way down the line, about 9 billion years in, our very own solar system finally shows up. All of that leading to this moment right here, right now.
So, with that incredible history in mind, let's start our tour. We'll begin close to home, and then we're going to venture out into the truly strange and wonderful corners of the cosmos.
This is our backyard, right? The Sun, the Earth, Mars, Jupiter, these are the names and places most of us grew up with. It's a pretty orderly system of planets just circling a single star. But you gotta remember, this is just one planetary system among billions.
And things get weird out there. I mean, really weird. That quote, that's not from a sci-fi movie. That's a description of a real planet. There are worlds out there where a whole year lasts just over a single day. Planets so close to their star, they're literally being pulled into the shape of an egg. Our solar system, it's just one flavor in a massive cosmic taste test.
Okay, now just let this sink in for a second. Our solar system is just one of hundreds of billions inside our galaxy, the Milky Way. And our galaxy? It's just one of hundreds of billions of galaxies out there in the observable universe. The numbers are they're staggering. They really point to the sheer scale of what we're talking about.
Thinking about a scale like that, it naturally leads us to some of the deepest questions humans can even ask. And this is where astronomy goes from just mapping the cosmos to trying to figure out its fundamental laws.
And you know, few things really capture our imagination and completely test our understanding of physics, quite like black holes. They are one of the most incredible predictions of general relativity.
So here's the key thing to get. A black hole isn't an object in the way we usually think of things. It's a region of space-time itself that has become so warped, so twisted, that its escape velocity is faster than the speed of light. It's basically a one-way door in the universe. Once you're in, there's no way out. So to even begin to grapple with these extreme ideas, scientists use visualizations just like this one. And it's not just a cool drawing, it's a mathematical map. Think of it less like a picture and more like a topographic map of a landscape. But instead of showing hills and valleys on Earth, it's showing these deep, deep dips and curves in the actual fabric of reality, caused by an immense amount of gravity. But this is where it gets truly profound. Back in the 1970s, scientists noticed this startling connection. The math, the laws governing black holes, they looked almost identical to the laws of thermodynamics, which govern heat and energy. And this wasn't just a coincidence. It was this stunning clue that there's a deep, hidden connection between gravity and quantum mechanics, a discovery that points us toward a single, unified theory of everything in physics.
So you might be asking, how do we know all this stuff? I mean, how do we peer across billions of light years to study things we can never, ever visit? Well, it takes some truly incredible tools.
And chief among them, of course, is the Hubble Space Telescope. Just by putting it into orbit way above the distorting haze of Earth's atmosphere, we gave ourselves this crystal-clear window onto the entire universe.
And has it been productive? Well, this number, 1.7 million,
That's how many observations Hubble has made since it launched back in 1990. Over 1.7 million times it has turned its gaze to some corner of the cosmos, and the data it sent back has completely revolutionized every single area of astronomy.
I mean, its achievements are just staggering. Hubble gave us the very first confirmation that supermassive black holes exist at the center of galaxies. It gave us the first detection of an atmosphere around a planet in a whole other solar system. It didn't just take pretty pictures, it made history, over and over and over again.
And what's so amazing is that this grand adventure isn't just for professional astronomers with access to giant telescopes. Not anymore. In our digital age, every single one of us can be an explorer. Seriously, it can start as simply as just going outside tonight and looking up. Or you can explore the universe right from your screen, browsing the millions of images that Hubble and other observatories have captured. But you can also go one step further and contribute directly to real research.
Platforms like Zooniverse let you become a citizen scientist. You can join a project like Redshift Wrangler and help classify distant galaxies, or cloud spotting on Mars to analyze the Martian atmosphere. You can actually be part of the process of discovery, right from your own computer. How cool is that?
So, we've journeyed from the dawn of time all the way to the frontiers of human knowledge. We've seen the familiar and the truly bizarre, the vast and the mysterious. The only question left is, where will your curiosity take you next? The universe is out there, and it's waiting.